Previously, we had a look at properties related to triangles, and now it's a quadrilaterals. When we say quadrilateral, so quadrilateral is four-sided closed figures. So generally speaking, four-sided closed figures are called as quadrilaterals. And there are a number of different quadrilaterals in our syllabus. The very first and the most popular one is rectangle. Rectangle is a type of a quadrilateral in which we have two pairs of equal sides. Then we have squares. We have trapezium. We have parallelogram. We have rhombus. And we have kites. So these are six different quadrilaterals in our syllabus, and all these six different quadrilaterals has certain important properties to be remembered. Because without you don't know the spatial property about these six shapes, you might not be able to solve the question whenever these shapes comes into play. We have all these properties listed down for all these shapes. Let's start with this rectangle first. Rectangle, there are two pairs of parallel sides. In rectangle, we have two pairs of parallel sides. Opposite sides are equal in length. Yes, we know that. This side and this side, they would be same in length, and AD and BC will also be same in length. All four angles are right angles, so 90 degree is a must at all the corners. Last, the two diagonals are equal in length. Diagonals bisect. Now, this is the most important thing. Diagonals bisect each other. Bisect each other means this side would be same as this side, and BE is equal to ED. So BE, this side, would be same as this. So this is the must property. And yes, since they would be bisecting each other, so all these sides would be equal. So instead of writing the double dash, you can also write the single dash here. So they all would be same here in case of rectangle. Moving onward, we have square. So square and rectangle, they have similar properties except one, that look, they have two pairs of parallel sides. All four sides are same length. All four angles are 90 degree. No, wait. In case of rectangle, we have two pairs of equal side, but in square, all four sides are same. What makes a square different is the two diagonals, they do bisect each other. But apart from bisection, there is one more spatial property associated, and that is the diagonals also intersect at 90 degrees. So all these diagonals, they would be intersecting at 90 degrees. These are all 90 degrees. These are all 90 degrees. So 90 degree means these are four different right angle triangles formed when the diagonals bisect. So apart from bisecting each other, they also intersect at 90 degrees. So intersect at 90 degrees means they would be perpendicular bisected to each other. Because they are bisecting, they are 90 degree. So that means you can also say that the two diagonals, they both are perpendicular bisected to each other. That means you can also apply the properties of coordinate geometry here. or coordinate geometry, since it's coordinate geometry is all about geometry of different shapes. So this is a important property to be remembered from coordinate geometry point of view also. So perpendicular bisector. So the two diagonals, they are perpendicular bisector to each other. Okay, parallelogram. Parallelogram, it's a tilted version of rectangle. So parallelogram and rectangle have certain properties similar, which are in parallelogram, we have two pairs of parallel sides. Opposite sides are equal in length, yes. DC, AB are equal. AD and BC are equal. Opposite angles are equal. Now this is interesting. Opposite angles are equal. Sometimes students, they miss out this property. Opposite angles are equal in case of parallelogram means this angle A is same as angle C, and this angle B would be same as angle D. Because in parallelogram, the opposite angles are always equal. And you can see based on the properties of parallel lines, you can see the letter C being formed. So whenever you have letter C means these are interior angles. Look, listen, letter C here. And there are two different types of letter C's. You have a letter C in this direction also. So that means you can also apply the properties of parallel lines here in case of parallelogram. Opposite angles are equal. Don't forget that. And diagonals, they do bisect each other, like the case of rectangles. But there's a slight difference between rectangle and parallelogram. In case of parallelogram, when the diagonals bisect, all the bisected sides are equal. But in case of parallelogram, this is not the case. In case of parallelogram, this and this would be equal, and this would be equal. So all four sides bisected, they are not same, like the case of rectangle and square. Moving onward, we have a rhombus. Rhombus like square. The rhombus also bisect each other and they make 90 degree. So rhombus and square, they have lots of properties same. Two pairs of parallel sides, all four sides are same because it's a tilted version of the square rhombus. Opposite angles are equal. Opposite angles are equal means whatever is there angle C, same as angle A. Whatever is there as angle B, same as angle D. Opposite angles are equal. Diagonals bisect each other at 90. So we have four different right angle triangles there. 90, 90, 90, 90. Four different right angle triangles when the diagonals bisect inside the rhombus. And then diagonals also bisect. Bisect means dividing into equal parts. This is, and this are same, this and this are same. So here in case of rhombus also, we can say that the two diagonals, they are perpendicular bisected to each other. The two diagonals, since they are intersecting at 90 degree, and they are also bisecting each other. So we can say that the diagonals are perpendicular bisectors here. Trapezium doesn't have lots of important words, at least one, and that is we have only one pair of parallel side. And because of one pair of parallel side, we can see the letter Z being applied. So yeah, parallel lines are there. Whatever is this angle, same would be this angle. That is only one thing what we can see in trapezium, one pair of parallel side. One pair of parallel side means the letter Z. And yes, the letter C also. This is letter C. Means the interior angles. Last, it's a kite shape. In case of kite, the property is we have isosceles triangles here, two different isosceles triangles. One isosceles triangle is ADC, and the second isosceles is ABC. Two different isosceles triangles. And the properties are the opposite sides may be parallel. Maybe parallel means it's not necessary they would be parallel. There are two pairs of equal adjacent sides. Yes, we have already seen that. AD and CD, they are equal. That makes ACD an isosceles. And same goes for AB and BC. AB and BC, these are equal. So ABC is the another isosceles triangle here. Diagonals cut each other at right angles. So diagonals cut each other at right angles. That means it's a 90 degree here, 90 here, 90 here, 90 here. So here again, and yes, after cutting at 90 degree, we see one diagonal bisects the other. One diagonal bisects the other. So that one diagonal is always a bigger diagonal out of two. So if it is bisects the other, it's also making a 90 degrees. So that means here also we can see the perpendicular bisector involved. And it's always the bigger diagonal out of the two, which is always a perpendicular bisector on the shorter diagonal. So bigger diagonal is the perpendicular bisector of the shorter diagonal. So these are all the important properties about different types of quadrilaterals in our syllabus. So we'll be practicing about all these different shapes in the next class. So for today, we have to keep it till here.